we're going to consider motion. We're going to consider motion in a straight line, linear. And we're going to consider motion in a circle, angular. And we're going to end up with some hopefully useful formulae considering angular and linear motion. Let's focus on the linear to start off with. So you've given me a list of really useful formulae. Let's start again. Tell me a formula that you know that's something to do with motion, in linear motion particularly. Yeah, linear velocity. Right, so what's the formula? Well, you told me with the unit in a way. What's meters the unit of?
Gravity per meter.
No. What do we measure in meters? Distance. Yeah. And what do we measure per second? What's that a unit of? Time. So what's the formula for velocity? Distance over time. Probably the most common formula that we would know to do with motion. Velocity is distance over time. Velocity is distance over time. Velocity and speed, what's the difference? Is there a difference? We use those two words, don't we? Do they mean the same thing? Who says no? Howard. Speed is the rate at which it's travelling. Velocity is not a force. No. If somebody said to me, oh, I want to go to Beccles, and I say, oh yeah, it's about 15 to 20 kilometres. What's the first thing you're going to ask me? What's that in miles? It's about 10, 11 miles. What direction? Which way am I going to head off? Oh, you need to go roughly west-ish. Okay. Speed tells us the magnitude of the motion that I'm travelling at, and that's a scalar. Velocity tells us a bit more. It tells us the magnitude, but also the direction, and it's a vector. Not something we're going to focus on particularly during this, but we will use, you'll see interchange the words speed and velocity. We're going to focus just on the magnitude of the velocity. So 30 or 15, 16 kilometers per hour, say, or 12 miles an hour would be the scalar. If I added the direction as well, it would be the vector. But we're just going to focus on the magnitude anyway, so we'll interchange them.
So you have when something reaches total velocity, you're saying where it cannot go any quicker, which would be
yes.
speed, wouldn't it?
Yeah, that would be the terminal velocity I think you're thinking of something. Falling, say. It can reach a maximum velocity. Cars can reach a maximum velocity beyond which they can't go. You're talking about the magnitude, not necessarily the direction. Because the size of that terminal velocity might depend on which way you're going, mightn't it? If you're going into the wind or with the wind, for example. So you might need to quote that, but generally you don't. So if I'm going from here to Beccles and it takes me half an hour and it's about 15 kilometres, what's my speed? 15 kilometres in about half an hour, what would I say my speed was? 30 kilometres per hour. So 15 kilometres in half an hour, 30 kilometres an hour. So a unit of speed might be kilometres per hour, 30 kilometres per hour. Now, does that mean I get in my car and 30 kilometres per hour, get to Beccles, stop, I'm there? So what am I measuring here?
Average.
An average, yes. So the average velocity And that's an important thing to remember, is distance over time. It's an average, the average. The total distance you travel divided by the time you take is your average velocity. It might be that you've gone at 30 kilometers per hour exactly for an hour, but that's unlikely, isn't it? Another formula to do with motion. Acceleration, Marcus. Tell me a little bit about acceleration. I agree with you over time, but it's not speed over time.
Distance over time.
That's average velocity. Yeah. If it's accelerating, what's happening to its speed? Sorry? Yeah, increasing. Or could it be decreasing? Would it still be an acceleration? Yeah, it would. The word acceleration means it could be increasing or decreasing, positive or negative. Deceleration is a word we sometimes use to mean reducing, but acceleration means both. Positive, you can have a positive and a negative acceleration. So if the speed is changing, what do you think we need to know to find acceleration then? Change in speed over time, okay? Right, Marcus, the change in speed over the time. Speed, time. Speed, speed. So let's say it's going linear speed. We use some symbols to represent what's called the initial speed. U is the initial speed. Came across that this morning. U and V are very common terms, okay? U means the initial speed. V means the final speed. So that could be U, and that could be V. And this is the time in between there, T1, and there, T2. So U, V, T1 and T2. Acceleration equals change in speed over time. So the difference between those two could be something called delta T, the change in speed between there and there. Change in time, delta T. Delta change in. That symbol there is the capital delta in the Greek alphabet, delta. And often used to represent change in. Delta, change in. And in this case, change in time, delta T. So instead of writing acceleration equals change in speed over time, I can write acceleration equals change in speed over time, delta T, the time over which I've measured that change in speed. How can I work out what that change in speed is if it starts at U and ends at V?
Distance.
Well, I want to know what the value is. Say u is 10 kilometres per hour and v is 20 kilometres per hour. What's the change? V minus u. So we have a formula for acceleration. V minus u over delta t. Change in speed over time. What time? The time for that change. Okay. Is it saying anything about what's happening between here and here? It's not. Okay. The speed could be changing like this. Or it could be changing like this. So what acceleration have we found here? In a way. Yes, this is an average acceleration. So this really is an average acceleration. Often in problems, though, we consider it maybe it's changing smoothly between there and there. So in many problems, this would be a straight line between there and there, but it doesn't have to be. So we've got a formula for the average speed. So if I want to now think about my formula sheet, I could write, and I hope you've not been putting all this on your formula sheet, by the way, you just put formulae on there. So for motion, we could add some formulae now. We've got some useful formulae. Average velocity is distance over time. S for distance or displacement. Yeah, V average velocity is S over T, where S is the displacement. Looking back here, remember we talked about speed and velocity, scalar and vector. In the same way, we have displacement as the vector and distance as the scalar. So displacement is, say, I've displaced by 10 kilometers north. That's a vector. I've got a distance of 10 kilometers distance. So again, we often only talk about the magnitude, 10 meters, 10 kilometers. We don't often consider the direction, but it exists. And so we talk about this thing called the displacement, and the common symbol for that is S. So displacement over time average velocity. Acceleration is V minus U over delta T, where V is the final velocity and U is the initial velocity. If I were considering just U, I was only interested in U. Let's say I started off at 10 kilometers per hour and finished off at 30 kilometers per hour. Started at 10, finished at 30. How would I find the average of those two numbers? Started at 10, finished at 30. What's the average speed? And how did I work that out? Add them together and divide by the number of R, which is 2. So here's another formula. V average equals U plus V over 2. So I've got two formulae for the average velocity. Using these three formulae, 1, 2, 3, and algebra, we can come up with three important formulae called the equations of motion. And each one is useful in a particular problem, as we'll see. I'm going to give you the formulae. You might recognize them as you see them. A little extension activity for those of you who are feeling like practicing your algebra is to try and arrive at those three formulae from this start point. So let's list these equations of motion. Insert blank page. So we've got what are called the equations of motion. And you can write these straight onto your formula sheet, because you will be using them. This is for linear motion. Anybody know them? Come across them before? I'll give you one. Anybody seen that before? Yeah, that's one of the equations of motion. V equals U plus AT. Might be the first equation of motion, probably is. Which number it is doesn't really matter. There are 3 of them. Faffing about with this and from the other equation you come across, we can write this. That's the second equation of motion. Remember, S is displacement, T is time, U is initial velocity, A is acceleration, V is final velocity. And fiddling around again, we can end up with this. 3 equations of motion. So number 1, V equals U plus AT. 2, S equals UT plus a half AT squared. Number 3, V squared equals U squared plus 2AS. Which formula you use depends on the problem you're given and depends on what you know. Have a look at them. Why do you think those 3 formulae were formulated or in the first place? What makes each of these 3 useful? Why do you think we group them together like this? Have a look at what's inside them. So each formula is missing a variable which might be useful to us. There's no S in this one. There's no U in this one. Sorry, V in this one. And there's no time in this one. And so we might consider that when we're trying to use the formulae. We might have to rearrange the formulae. So there's a little bit of algebra involved. We'll certainly need to decide which formula to use and make sure units are consistent, as we mentioned before.